Yo, hey guys. So welcome to the Nerdatorium. I got a crazy project. I was working on my chiller a little bit, and I decided that my old radiator that I used during the winter is leaking water all over the place. No, not really. It was kinked up. This is an old window air conditioner radiator that I just put some cruddy aluminum on and a fan in order to push the air through and whatnot. Who cares, a crud? But power adapter. But the thing is it didn't work real great because it was hard to move around and stuff, and it was kind of botched. But in the winter, I also have a wood stove, so that it gets kind of dry. So what I'm going to do is, you see a whole lot of crud here, including a scuba cylinder, which is just going to be used for a coil and some copper. I can't promise that we're not going to use a whole lot of duct tape today. So I'm going to take this bucket, and I'm going to turn it, for now, just into an air-cooled radiator with the copper coils. But eventually what I'm going to do then is I'm going to turn it into a evaporative cooler. So basically what it'll be is there'll be some coils of copper in there, some water pump. We'll spray some water on the copper, and then that what it'll do is it'll evaporate off and it'll cool the copper down, and it'll also humidify the house while doing it. So I'll get heat and humidity, and it'll help things out in the basement. So basically what the plan is, I'm going to cut a hole in the top here for the fan. We'll mount a fan on the top. We'll coil up some copper around here. That'll go into the center here. And then we'll put some big holes in the side for air to come in. That'll allow just natural circulation, and then we'll put a control on for the fan, so that way we can turn that fan on and off when the water temperature requires it. And then eventually what we'll do is we'll put a secondary base in the bottom, so that way the water can drain out, and we'll put a pump and stuff, but that's future videos. So anyway, here we go. Get started. You learn by doing, so we'll see how this goes. Oh yeah, getting personal with the tank. So this is going to be long and boring, so I'm just going to cut ahead. Okay, so yeah, you can see we got the first coil here done, and I got to braze another piece on. Anyway, so something that I've learned over the years for deburring, if you actually just use a pair of needle nose, it's a great way to get the full port out of your copper without cutting it and getting burrs. Because sometimes those deburrs, you can get particles in your system. Like I said, I'm a refrigeration HVAC tech, so that's never any good. But there you go, that easy. Braze this thing up. Fire! I didn't feel like busting out my oxy torch for this like one little joint, but preferably I do like my oxy torch. Bam! All right, we're good. Look at those sexy joints. Now, the important thing is with your brazing rod, it's always hot on the end. Dude, I can't tell you how many times I burn myself. You got to watch it. So let that air cool for a second or two, and then we'll cool it down, and we'll, see, I just told you about it, and I went and put it on the wood table. So, and we'll give you coiling again. Yeah, that's hot. All right, there we go. Let's get her removed and see what she looks like, huh? Oh, she's tight. Ugh. Spin it the wrong way, maybe. Give her some jigglies. There we go. Cool. There we go. It's an ugly mess of copper, and there's probably not going to be a lot of airflow through that, so we'll spread it out once we get into the bucket. Let's see how it looks out. Looks. Let's see. So there's our bucket. Yeah, that's good. So we'll stretch her out a little bit. Yeah, that got really dense. Maybe I'll try to put this down the stairs. Okay. Well, there we go. Something of that nature. That'll do. That'll do. Okay, so I got the holes all out. We're gonna drill a hole in the top here for the fan. I've got it's actually 108 millimeters, it's 4 1/4 inch. So it's a little bit small for a 120 millimeter fan, but it's gonna be good enough because these fans aren't gonna have enough static pressure to really get full volume anyway, so it'll be fine. So if you guys aren't familiar with using big hole saws like this, you wanna run them in reverse when you're first drilling your pilot. Otherwise, your teeth will catch and it'll just freaking tear your plastic apart. So, convenient enough, this bucket has a mark on the top, so I already got center. There you go. So I'll probably do the pilot holes off cam for this. I'll bust out the drill press and I'll line them up so that way they're all nice and square. But there you go. See, that'll work just fine. Now, like I said, eventually what we're going to do is, so the air is going to come in through the side, and then it's going to come up from the outside, and there will be like a mesh or a felt on the outside of here that'll hold the water. And then the air will pass through and then vaporize and have the moist, warm air come up out through the center. That is our goal. So I'm going to put a couple on the sides, but I want to have them up a little bit so that way there can be room for water accumulation at the bottom. 3 1/4 right there. That will give us 2 inches from the bottom. There we go. I'll probably put one on the other side, and I think that'll be enough. I should probably put it in a trash bag. I got one right over there. Okay. There we go. Let's put our coil in. Let's make sure. I gotta put notches in here yet, so we put that on top. So here we are. Set. Depth should be good. That'll do. That'll do nicely. Cool. Boom! Look at that. Almost like I sort of measured for it. So I'm going to just attach the fan off camera, put it on there because it's not going to be that exciting. And then what we'll do is I'll get everything hooked up and we'll do some benchmarking in the basement and see how it performs. Okay guys, so back in the nerdatorium itself down here in the basement, I've got the radiator bucket, coining that term, it's mine, don't steal it, hooked up. I got the water filled in and all that fun stuff, air bled out. I've had it running for about 2 hours now while I was taking a look at the earlier videos. and I have my meter set up on min-max. The temperature has been slowly climbing, much slower than it normally would. I don't have anything really running right now, but we're going to run some benchmarking. So this is on the supply temp right now. It's showing the 82 degrees. We can look at our min-max here. Maximum is 82, right at what we're at now, and it was down at 79. So what we'll do is I'll reset my min-max, and we can put it over here on the output, and hopefully we'll see it go down. Yeah, it's 81.8 compared to the other one, which was at 82. So you can see there's about 0.4 half a degree difference right now without the fan running. That's without any load on the system. So what I'm going to do is I'm going to take I looked earlier, my reservoir is at about 83 degrees. That's a little bit warmer because you get the loss in temperature in the line. Anyway, I'm going to get some programs running. We're going to try to get the water temperature up to like 85 degrees, and then I will kick the fan on. So here we are. So here's my baseline. CPU temperature at 42C, 107 degrees. You don't go off of this temperature here. It's not accurate. And then our graphics card, it's in Crossfire, so all three of them, it's averaging out to 100 degrees Fahrenheit, 38 degrees Celsius. So I'm gonna run Firestrike in extreme mode, so I can see if I can still capture here while doing it, and I'm just gonna run demo so it'll loop. So let's see what happens. Okay, you can see things starting to ramp up. CPU temperature is getting up to 120 degrees, and the GPUs, well, they're still at 39 Celsius. There you go. Yeah, 111. Now it's actually running. So let's just run for a little bit, and we're gonna watch our temperatures. But our water temperature is approaching that 85 degrees, so I'm going to kick the fan on at this point. So before I do that, I'm going to just check my return temp. Yeah, so 84.7. Let's see what we're at over here. So I'm going to reset the range again so we can see it, confirming it going down. Yeah, so that was at 84. Yeah, so I'm getting a temperature drop just as is, almost 2 degrees now. So as the water is warming up, we're getting more of a natural draft through the bucket, and it's doing its thing. So let's plug the fan in and see what we can get. 82 degrees. Let's check our supply. What are we coming in at? I really should hook my my other gauge up so I can see both at the same time, but I don't feel like going out to the truck and getting it. At 84.4. – 82. So about a 2 degree drop. Yeah, our CPU temperature is back up to 52, but it looks like our GPU temperatures are going down, and that's where our real load is at. Let me take a quick walk over here. We're at 86 degrees, so that's not cool. What I'll do is I'm going to let this run for a little while, and then I'll bring you back. Okay, so it's been running for almost 20 minutes now. Actually, it has been running for 20 minutes with the benchmark running. My water temperature is 87 degrees Fahrenheit now. And you can see how my outlet's at 85.9. So although this thing is removing heat as is, it is not enough to keep the system benchmarking. at least at a comfortable level that I would want to keep it at. It is fine. It's well, everything's well within range. I think my CPU temperature will bump up to like 51 Celsius every once in a while, and that's perfectly fine. But the whole point of this thing is to make it into an evaporative cooler. So that'll be the next step. All right, well, thanks for watching. I'll put some more details in the description with some more numbers and stuff to give you an idea what actually happened. If you haven't watched the chiller overclocking video, you should watch that. And there's also the actual video of all of this junk so you can see everything. But thanks for watching. Like, subscribe, leave comments on ideas or suggestions or things that I did in the video that you don't like or do like, so that way I can get an idea of what to go for in the future. So, Mr. Ideas signing out.